Alright, today we're doing Chapter 3, Section 10, Converting Between Fractions and Decimals. And this is important. This is going to keep coming up. So please, if you're not going to learn one section from this chapter, don't let it be this one. This one you really need to know. So, okay, we'll just jump right in. So we're going to look at two different kinds of decimals. One, decimals that stop or terminate. Maybe you saw the old Terminator movies from the 80s. That's what I grew up with. And decimals that repeat. So that's my A and my B. And I'm going to start with the terminating decimals. So for these will be things like, if you look at the two examples, you have 0.7, 0.894. They don't keep going forever compared to repeating ones like this. So, all right, first these. So right over 10 with the same number of zeros. Same number of zeros as decimal places. Okay, what I'm trying to get at with this here is if I have this 0.7, I have one decimal place there. So 0.7 would be 7, and I want to divide by 10. And because I only have one digit after the decimal place, I only have one zero, so it's 7 divided by 10. The second thing is if you can reduce the fraction, then you should. So I'm going to say reduce fraction if possible. So if you can reduce the numerator and the denominator of the fraction by the same number, if you can divide both those by the same number, then you do it. In this case, 7 and 10, they're not both divisible by something, so we are done. The next one, 0.894. I'm going to reduce 0.894. The top of my fraction, I just write my 894. I don't have a decimal place there. And now it's going to be right over a multiple of 10, but I need to have 3 zeros, so I'm going to divide by 1,000. So 0.894 is the same as 894 thousandths. And you can think back to up this first one here, 0.7 is the same as 7/10. But now we can reduce this. And maybe I should say I have 3 zeros because I had the 3 decimal places there. And you could go through and try to find what's the greatest common factor of both. I usually just go through and say, hey, they're both even, I'm going to divide by 2. So if I divide by 2, that's going to give me 400, so that's half of 800. Then 94, 90 would be 45 plus half of 4, so 47. So I have 447 divided by 1,000 divided by 2 gives me 500. So I'm up to there. And then we're going to get through and do divisibility rules later on in life. For now, we'll just say, hey, we're done. Could divide the top one by 3, can't divide the bottom by 3. You'll get that stuff later. If you are allowed to use a calculator with a fraction key, something you could do right now, or you could do with 894 divided by 1,000 possibly, is put in the numerator, so 894 fraction key 1,000 equals. That'll automatically reduce it for you. Some fraction keys, though, some calculators can't handle 4 digits in the denominator, but they can handle 3, so you could get this far and then type it in. If you weren't watching the notes from yesterday or the day before, your calculator, if it's a scientific calculator, should have a key like that would put it into a fraction. If you have a graphing calculator like a TI-84 Plus, those, if you do the alpha button and then I think it's the Y equals button, that'll take you into a menu where you can find a fraction key. If you're doing a TI-83 Plus, you could do 447 divided by 500, and then math, enter, we'll change it into a fraction. And the math key is 2 below the second button. All right, let's move on. Repeating decimals is going to be really similar, but instead of dividing it by a multiple of 10, like 10 or 100 or 1,000, we're going to divide it by a multiple of 9. And so right over 99 with the same number of 9s, write it that way, as repeated digits. And then reduce fraction if possible. So we go to an example. So I have 0.36 repeating. So technically that goes on for forever, but the number of digits that are repeated is just 2, because it's 36, 36, 36, 36, 36, kind of for forever. So I'm going to write this as 36 over 99. I have 2 repeated digits, 2 repeated numbers, so it's over 2 nines. Now for reducing it, because we have 9s in the denominator, 9 or 99 or 999, typically dividing by 9 or by 3 is going to be pretty good. Often People divide by 3 for both of them, but if we try dividing by 9 first, 36 I know could be divided by 9. That gives me 4. So I'm going to just write a little divided by 9 here. Divided by 9. So I get a 4 in the numerator. I get an 11 in the denominator. So 0.36 repeating is the same as 4 over 11. Next one, 0.5 repeating. Well, that would be 0.5555555 for forever. But we only have one digit that repeats, so I put a 5 in the numerator, and it's not a 0.5, it's just the number that repeats without the decimal. And then since it's only one number repeating, I divide by 1/9, so I get 5 over 9. You can say, well, could I divide by 3? Could I divide by 9? And you could do that for the 9, but not the 5. The 5 is a prime number, which you'll learn about later if you haven't already. So that reduces to 5/9, or is already the lowest fraction. So that's the first part, kind of the first half of the notes. How do you change a decimal to a fraction? Now we want to say, well, how do you do that backwards? So converting a fraction to a decimal, that's going to be the numerator divided by the denominator. So numerator divided by the denominator. So if you're allowed to use a calculator, that's sweet, because you just do for this first one 3 divided by 4, cha-ching, copy down the decimal answer that it gives you. Some calculators don't give you a decimal, it'll write it as a fraction even when you type in the division problem. So then I think they're all Casio calculators. There's a button that looks something like this here. If you press that, it'll change it from the fraction to the decimal. Okay. Let's say you can't use a calculator though. Well, then we could rock it old school. And well, 3 divided by 4. So I have my 3. I do my little fraction thing, and I have my 4 out in front. Now, 4 doesn't go into 3, which seems like a problem, but we are trying to get a decimal. So if you think to earlier in the chapter, I could put a point right there, and I could take that up above the little fraction sign. And I can add zeros as many as I want after the decimal point and not change the value of our thing. And we shouldn't need that many, so I'll make it at least a little bit shorter. And now I could say, well, 4 doesn't go into 3, but how many times can 4 go into 30? So I think, okay, 4 times what? Well, 4 times 7 gives me 28. So I could put a 7 right there. 4 times 7 is 28, so I'll write my 28 underneath the 30. Then I subtract to figure out, well, how much is left over after I do 7 multiples of 4, and I get a 2. Well, 4 can't go into 2, which it shouldn't be able to if we did the first part right, but now I can pull down another 0, and I have a 20. Well, how many times does 4 go into 20? Well, 5. 5 times 4 is 20. So then reduce the 20, and I get a 0. So 0.75 then would be the answer to this 3/4. 3/4 is the same as 0.75, or 0.75 if you want to make it look pretty. And we could do that same thing for this next one. So punch it into a calculator or do the long division. I'm going to do the long division because that's how you'll be expected to do some on your quiz, at least for my class. So 5 divided by 6, we get that there. 6 doesn't nicely go into 5. So we can start adding zeros after the decimal point. And we can say, well, how many times does 6 go into 50? Well, 6 times 7 is 42. We did that, or did a 3. But that, we could go higher. 6 times 8 is 48. So then I could subtract 48 from the 50, like so, and I get a 2. Now, since we're after the decimal point, we can add zeros and not change the value of our original number any. So I pull down a 0. All right, 6 goes into 20. Well, we have 6, 12, 18, 24. So it'd be 3. 6 times 3 is 18. When we do that, we get another 2. So some people already are starting to see what's happening here. Because when we subtracted here, we got a 2. Now when we subtracted here, we got a 2. So there's something significant about that. If you didn't catch on, let's keep going and kind of see what happens. Well, I could add a 0, pull that 0 down, and I have a 20, just like before. Well, 6 times 3 gives me 20. I'm sorry, 6 times 3 is 18. I'm getting ahead of myself. So then I have another 2 left, just like before. So I could add in another 0 and pull that down, so I have a 20. And so hopefully you're starting to see the pattern, that it's just going to always give me 20. And 6 can go into 23 times with 2 left over. So I'm going to get this 0.83333333, a whole bunch of stuff like that. So the way we should write it, though, is perhaps 0 point, but then we have at least the 8, 3. Only the 3 is repeating, so we only put the bar over the top of the 3. So 5 over 6, 5, 6 is the same as 0.83 repeating. So that's it for this section. And if you have questions, let me know in class. Thanks.